Hi everyone, thank you for watching my video presentation on the Capstone project. I'm Darnell Roan, and the title of my presentation is Collaborative Learning through Pair Programming, Effects on Employees. So for my presentation, I would be looking at, as the title states, pair programming and how it has an effect on employees' productivity and efficiency in the workplace. Okay, so starting off with the problem statement for my project. So many organizations are slowly shifting away from the use of slow-paced waterfall software development lifestyle, also known as the SDLC, and are beginning to transition to a faster, iterative environment by implementing the use of the Agile framework. So I'm a Scrum Master at a large IT banking company. So really what a Scrum Master is, if you're not familiar, it's a project manager. So I go through a manager project, making sure that things are going as expected. And we also go through the Agile framework. So Agile framework is a little different than SDLC, and I'll get to that further in the presentation. All right, so despite being instructed to complete tasks using collaborative Agile frameworking, many employees feel that they need to continue to work in an individual manner. So some of the points of Agile, the main point of Agile, actually, I should say, is collaboration. In the Agile environment, collaboration is key. The goal is to get employees away from working in that silo that they're accustomed to working to. And I come to find out my job and many other places as well when I speak with others is that, when teams first start moving to Agile, even for probably the first few years or so, they still continue to work in that silo, even though they may work a little better as a team, but they still kind of work in an individual manner. And some of the things that I see that are causing that seem to be like a lack of training type of thing. They don't know that all the assets of Agile that can help them collaborate. Another thing would be the company culture. A lot of things are incentivized based on your individual performance, and people really don't like to, help people, because that means they might get ahead of them. So that's another reason why people continue to work individually. And another thing that I have marked is just old habits, kind of teaching an old dog new tricks, right? People are so used to working by themselves that it's kind of a difference to collaborate with others on a day-to-day basis. So being that as it stands, many workplaces often neglect to use some of the core elements of the Agile framework that further promote collaboration due to concerns of negative impacts on employees' productivity and efficiency levels. So a lot of companies believe that, why would I have two people working on one piece of code or one project when I could have one person working on two different things at one time? That obviously saved the company more money and, in their minds, more time and effort, but that's not always the case as well. I always call it the adage, two minds are better than one type of thing. So if I have two of my best people working on my project, I should be able to cut that time in half. And that's exactly what pair programming is. So pair programming, I have two people working on one set of code. So one person would be the driver, who's actually doing the code, and others participating and guiding the person through, making sure they're not making any mistakes and just giving ideas and feedback as well, back and forth. So that's two of the facets that pair programming gives off. All right, then my solution for these issues, which I implemented in my paper, was to train employees on Agile basics and implement pair programming for a 6-week period and evaluate the results on employee efficiency and productivity. All right, and then we'll continue to get into that in the presentation. All right, so what were my research questions? So all of my research data was based upon these three questions that are listed here. So the first one being, does direct collaborative learning help to reduce the amount of time that it takes employees to deliver complex development items? 2, can collaborative learning through the use of pair programming increase the productivity and efficiency levels of employees? And 3, can collaborative learning increase the quality of the code that employees are delivering, i.e. the number of defects found, the amount of lines of code being used, etc.? And again, just to reiterate the purpose of the project, all three of these questions are being used to identify the extent that collaborative learning has an impact on employees' productivity and efficiency. All right, so moving on to the goals of this project. So my three goals I had for the project were employees would know how to effectively pair program with other employees. Employees' efficiency and productivity levels will increase with the use of pair programming, and the amount of time that it takes employees to complete complex development tasks will significantly decrease. Also some working definitions as well, just as I throw terms out as I go through this. So the way I'm defining efficiency for this project is the amount of defects identified after the code completion. So defects are obviously a bad thing, right? That means something is incorrect with the code. So it doesn't really mean you're inefficient, but that's how we're going to measure it here. Definition 2 would be productivity, is the amount of time needed for a complex task to be completed. That's pretty straightforward. And the third point would be a complex development item. So that would be any development item that is expected to take between 40 to 50 hours of more of development. So, and by development, I mean having two employees sitting at the desk and typing out the code to complete it. All right, so my methodology. So here listed are the 5 tools that I use to measure if my project was successful or not. All right, the first was an agile knowledge pre-assessment. So here was a simple test that the employees were given covering the basics of agile. They were given this before implementation and after implementation to see where they are, their understanding of agile is and what they learned and what changes were post-intervention after we covered the basics of agile as well. The second was a pair programming questionnaire. This was a questionnaire to identify employees' opinions and thoughts on pair programming to see if they thought that they were ready to pair programming or actually knew how to execute. The next was a pre-intervention performance stats. So these were, again, stats of the team before, how long they were taking to complete complex development items, how many defects were found, things such as that, and the completion percentage as well. Also, post-intervention stats were taken as well. So again, after the training was implemented, I tracked the same metrics that were just mentioned previously. And also last was a post-implementation employee survey, which was an anonymous survey, just to kind of get feedback from the employees to see how they thought the project had went for them. All right, so next we'll get into the results. So the results here on this page are covering their productivity portion of the project. So after the t-test was conducted, the results indicated that there was no statistically significant difference in the amount of hours spent on complex tasks pre and post intervention. So looking at some of the data here, pre-intervention, the team spent 38.5 hours on complex tasks on average, and post-intervention, the team spent 37.2 hours, which is, again, not that much of an increase, or decrease rather, I'm sorry. Again, so not much shown here in the t-test, but the team did show that the team did start to complete more complex tasks, even though they used the same amount of average time to complete them. So pre-intervention, the team completed about 66 complex tasks per iteration that they selected to do during that sprint. And post-implementation, they completed 74% of those tasks. So the completion percentage rate went up, but they still use the same amount of time to complete those items. All right, and then going to the next slide. Here is just a chart showing that data for the completion task, completion percentage rate. So again, it's just a visual representation of that data that I just discussed in the previous slide. And again, week 6, there was no data shown for post-implementation, post-intervention, because we had to cut the study a little bit short due to everyone shifting to work from home due to everything that's going on. All right, so moving on to efficiency. So again, another t-test was ran, and the results of the t-test indicated that there was also no statistically significant difference between the number of defects that were found pre and post intervention, as p was greater than 0.05. So post intervention, the team averaged a little more than one less defect. So pre intervention, the team averaged 2.6 defects that were related to complex tasks, and post intervention, they average 1.2 defects. So that's definitely one less defect. I know one doesn't seem like a lot, but one less defect, that's less man hours spent trying to triage that defect and correct it. So that's definitely a significant change that was shown, even though the t-test did not show much of a change there. Also, pre-intervention, the team in the 6 weeks that I researched prior, 16 defects were open and triage related to complex items. But in the 5 sprints post-intervention, there was only a total of 6 defects. So definitely a large decrease there as well. So even though the t-test, again, didn't show any data that were strides, it did show that the team did make some improvements there as well. And again, here's just another chart showing some of that data that we just covered. I know I'm going kind of fast, but I know I'm getting well over time here. All right, then for the final page of results, for understanding the Agile basics. So for this, again, another t-test was run, but this time the t-test did indicate that there was a statistically significant difference in the employee's understanding of the basics of Agile as a pair programming as P was less than 0.05. All right, so the mean of the test scores increased by 26 points as the average score on the test increased 90%. On the second time taking the test after the entire study was completed, 8 employees scored 100% on it test, and before only 2 achieved that score. 13 and 15 of the employees all scored at least 83%, and why just 2 employees failed that test. So yeah, definitely a large improvement in the employees' understanding of the Agile framework, which was good for sure. I think here is again, it's just another chart showing that data here as well. All right, so moving into the discussion as I wrap it up. So again, even though 2 of the t-tests showed there was no statistically significant data changes that were made pre and post implementation, as I stated before, the team made quite a few strides there. I definitely saw improvements, and I think over time, if the team had continued, definitely would have made more strides. I know we were working on a brief window, just trying to complete everything. And then moving on to a few limitations of the study. So again, some of the key limitations, I wrote about this in the paper as well. The 2 key ones I wanted to call out are the varying years of experience within the Agile team. So some developers were developers for 15 years. We have about 3 or 4 people directly out of college. So definitely varying levels of experience and varying levels of experience of Agile as well. At that point too, also varying levels of, again, understanding of Agile and software development, and also varying levels of understanding with the code base. So obviously, right, the longer you work on the code base, the more familiar with it you are, you don't really have to go searching and research. As opposed to being new, then you kind of have to just kind of figure out how things are working. All right, then my last point, I think for any future studies, I think that if someone is continuing this research, I think that they should look to implement this with a more experienced Agile team who has a better understanding of the Agile framework as well. That way they should be more familiar with pair programming, maybe have done it before. And I think that this would help show the success of pair programming a little better than my research results did. But all in all, the team was very supportive. I think a lot of good data was shown as well. Pair programming is effective. And I think I have some good data here that proves that. All right, thanks everyone for watching. I know I'm well over time, but I had a lot of information. Thank you.